You know, I've been thinking, how exactly do we know that it's going to be hot one day, cold the next, even when it's sunny outside? Like, how does the sun create all this energy, and how does it reach a big place like Earth, even though when the sun's 93 million miles away? Well, I have a good question for you. Let's take a look at the weather and how thermal radiation affects our everyday lives. Us, plants, trees, animals, that thermal radiation is the main concept, is what I'm trying to get at. There are four basic modes of heat transfer. These occur within the organism, and the interface between the organism and its environment, and between the environment and thermal surface of an organism. Even this grass is emitting thermal radiation, even if we can't see it. Even my body, I am losing energy, gaining it, my metabolism is generating it as well. All organisms are continually exchanging thermal or heat energy with their environments by these four modes. The rate of thermal energy exchange depend on the thermal characteristics of the organism and its environment, and the interaction between modes of heat transfer between the two. As you can see by this really detailed diagram, that everything in our everyday lives is either reflecting, losing, or absorbing heat. Even trees that we eat have infrared radiation bouncing off of them. So far away, heat can be transferred from one place to another by three methods. One, conduction in solids. Two, convection in fluids, liquids, or gases. And three, the best, radiation through anything that will allow radiation to pass. Well, that, my friend, is heat transfer by radiation. The sun. All bodies radiate energy in the form of photons moving in a random direction, with random phase and frequency. When radiated photons reach another surface, they may either be absorbed, reflected, or transmitted. The behavior of a surface with radiation incident upon it can be described by the following quantities. Alpha being absorbance, the fraction of incident radiation absorbed, rho being reflection, the fraction of incident radiation reflected, and tau being transmittance, fraction of incident radiation transmitted. Both of these must equal 1, a unity number. Pictured below are the three pathways for radiant energy to reach a plant or an animal. Energy that is reflected from the surface is of no thermal benefit to an animal or plant. Reflected energy in the visible portion of the spectrum is detected as shades of gray or as color, depending on the receptors of the organism detecting the light energy. Transmitted solar energy is of no value to an animal, and all animals except the smallest protozoans are especially opaque. The leaves of plants, however, transmit some solar energy. Absorbed energy becomes a part of the thermal and physiological regime of an organism. Looking at these pictures, you can really get a good feel for how and what radiation looks like. Well, radiation is a transfer of heat by means of electromagnetic waves. To radiate means to send out or spread from a central location. Whether it is light, sound, waves, rays, anything, if something radiates, it protrudes or spreads outward from a region. A transfer of heat by radiation involves the carrying of energy from an origin to the space surrounding it. The energy is carried by electromagnetic waves and does not involve the movement or interaction of matter. Just like in fluid flow class, the radiation rate equals K times T to the fourth, K being some constant like the Stefan-Boltzmann constant. The harder the object, the more it radiates. The sun obviously radiates off more energy than a hot mug of coffee. So when we think about weather and how heat travels, we can kind of think of the sun as the middle, like where everything comes from, because like from the conservation of energy, nothing is created or destroyed. What is terrestrial radiation? Since the surface of the Earth has a comparatively low temperature, it radiates electromagnetic waves with wavelengths of 3 to 80 microns, which fall into the infrared portion of the spectrum, which is invisible to the eye. The surface of the Earth cools down because of its intrinsic radiation. The flow of intrinsic radiation of the surface of the Earth is directed upward and is absorbed almost entirely by the atmosphere, thus heating it. The atmosphere, in turn, sends counter-radiation toward the surface of the Earth at approximately the same wavelengths, which partially compensates for the loss of heat by the surface of the Earth as a result of its intrinsic radiation. The difference between the radiation of the surface of the Earth and the counter-radiation is called the effective radiation. Together, they exceed terrestrial radiation for most of the day, and the surface of the Earth heats up. Terrestrial radiation is one of the most important factors determining the thermal conditions of the surface of the Earth and of the atmosphere. This radiation is my favorite because without it, we would not be here as humans. Thank you for watching.